Welcome back to the Walnut. In this lesson, I am going to teach you a very interesting application of identity for finding the squares of such big numbers. It's a very effective application method. Most frequently, you may face the situation to find the squares of such large set of numbers as part of a calculation-based question. Which way you can find the squares of numbers easily? So here, the basic requirement for the application of this identity-based method is simply you have to familiar with the squares up to 15. Hope you all have the basic idea about those are squares. So most of the serious students, they are seriously focusing or preparing for their aptitude kind of exams are already by heart the squares up to 25. If you are not one among them, try to improve the range of your squaring table. So here, the tables of squares up to 15, that's the basic requirement for these applications. Here, I am using a very simple identity which is most commonly, most famed, that is a plus b the whole square. What is a plus b the whole square? Its expansion is a square plus 2ab plus b square. So there are lots of different terminologies for using this kind of squaring method. One of the common terminology is duplex method. But it's a basic step of duplex method. Here we are mainly applying this identity. We can check how to apply this identity for finding the squares of such number. First, we are considering a simple task. We have to find what is 31 square. So how we can apply this identity a plus b the whole square for finding the square of such a two-digit number? What do you want to do? Here you just split it as two groups. This 1 is B. This 3 is A. So, and as per this expansion, first you have to find out what is B square. And that's a very important point. In this squaring trick, you have to start your operation from right side. It's a right to left operation. So here, first part, that is what is b square. Here b square, that is 1 square. Because in this 31, 1 we are considering as b. And what about the second step? Instead of this plus, I am separating the step of operations by using bars. So the second step, that is 2ab. So here this is 2 into 3 into 1. And the third step, that is a square. Here a is 3. Therefore, this is 3 square. And you can write down these all values separately. What is 3 square? 3 square is 9. And what about the second step? 2 into 3 into 1. That is 6. And the last value, here 1 square, that is 1. So now we got the square of 31. Is it an easy method? So you can apply this method effectively for any type of two-digit numbers. But we need to learn something more important points. So here we just consider the second example, that is 43 square. First step, what is b square? Here b is 3. 3 square is equal to 9. And second step, 2ab. In this case, 2 into 4 into 3. What is the value here? That's equal to 2 into 4, 8 into 3 is equal to 24. And the last step, that is 4 square. What is 4 square? 16. 16. Now we got the answer, but you have to understand a kind of arrangement while we are selecting the output from these old values. Can we write the square of 43 as 16249? No, that's not right. So there is a trick that you have to keep in your mind while applying this identity. How many digits in this rightmost group how many digits in the rightmost group. So that much digit you have to take from each step of operation. That's very simple in this case. Here we just consider A and B. Both are two single digit values. So therefore we have to write only one digit from each step of operation, and then you have to start from right side. So here the rightmost digit is 9. So there is not any other observations of the set of values in this last group. Now we have to consider the next step, that is 24. What do you want to write as the tens place digit of our answer? Only this 4. So you have to write 4 here. And what happened with this 2? You have to take this 2 as a carry forward to the next step. That is simply 16 plus 2. What is 16 plus 2? That's equal to 18. So now you got the answer easily. 43 square is 1849. Is it interesting? Then, once familiar with this application style, you can do these entire operations by mind. So now you become confident to find the squares of any 2-digit numbers. So we can move to the 3-digit numbers. How we can effectively apply the same method for finding the squares of 3-digit numbers. Don't forget, our basic requirement is your by-hearting skill. So, minimum requirement for the application of these all questions that you have to familiar with the squares up to 50. But while we are applying this method for 3-digit or 4-digit numbers, there are some restrictions. So, if you have to improve that range of squares or the square table, you are by-hearting tables, so then you can find the squares of any number, at least up to the 4-digit numbers. You can apply the same method. I will explain here. Suppose 112. Here we know that we are using the identity a plus b the whole square. A bit confused one. Because in our present task, that is 3-digit number. So how we have to separate that as a and b? If there is one more element, that is c, a plus b plus c, then we can check it. But here we are using only this identity. So how to split this value? So you can split it as either 11 and 2 or 1 and 12. It's better to keep the possible or the maximum number of digits on the rightmost group. I will explain the trick behind that kind of application. So here I am splitting this value as 1 and 12. Got it? 1 and 12. This 1 is A and 12 is B. So as I already explained the concept, how many digits in the rightmost group, that much or that many output you have to take from each step of operation. That's the basic trick. So that means here the rightmost group or the value represented by B is a 2-digit. Therefore, in each step of operation, you have to select 2 digits. So anyway, we can expand it as per this identity. Here the first step, that is b square. In this case, 12 square. What is 12 square? That's equal to 144. That is 12 square. And second step, that is 2ab. 2ab. Here, 2 into 1 into 12. What it is? That is 24. Clear? And the last step, here a square, that is 1. What I mentioned earlier, we have to take the 2 digits from each step, rightmost 2 digits from each step. So here you have to select only 44 and take this 1 as a carry forward to the left step. Now this is 24 plus 1. So no doubt you can directly write the next 2 digits are 2 and 5. Whether there any carry forward value to the next step? No. So you have to write the last one directly. So you got it easily. So 112 square is nothing but 12544. Yeah, it's an amazing trick. It's a magical one. So once you're familiar this method and you have to be proficient to do these operations by mind, you can perform miracles there. So you will get lots of time and you can reduce your time consumption for the simplification process of this numerical type of operations. Hope you got the idea or the extension of this idea for finding the square of such a 4-digit number. Got it? So how to separate it? This is 1211 square. How we can separate it? Anyway, we know that we can easily split this as 12 and 11. And it's easy to find the square of 12 and 11. So you have to split it like this. And we are proceeding the same expansion here. The first part. So that is 11 square. What is 11 square? That's equal to 121. Second step. 2 into 12 into 11. So what is 2 into 12? 24 into 11. 264. You have to write the second observation, that is 264. And the last step here, that is 12 square. So what is 12 square? That is 144. Here again, you just observe how many digits in the rightmost group. There is exactly 2 digits. Therefore, take only 2 digits from each step of operation, 21, 64, 44. But don't forget there are some carry forward values too. First, you have to write this 21. Got it? So now, this 1 as a carry forward value to here. Therefore, the 64 become 65. And here we have 2 as a carry forward value. So this is 144 plus 2. That's the last step. You have to directly write that as 146. Clear? So we got it easily. The square of such a large number, 1211, such a 4-digit number, is square as 1466521. It's a magical application. So you can save your time. And you will get some questions directly as the application of the squaring methods. Now the challenging step. We are going to find the square of another 4-digit number. But it's a most favorable type of number. How we have to arrange the operators here, that's a very important point. This 2014. So that 0 is a friendly one. It will support as a lot. So while we are splitting this one, can you find out which is the way or the suitable way for the separation of these values in the form of A and B? Is it the right way to split it as 20 and 40? No problem, that's the right way. But the most convenient and time-saving way is this as 2 and 014. What is the trick here? I already mentioned that point. If you are able to handle with the maximum number of digits in the rightmost group, that will save your time. So here, what's the trick? Its rightmost group contains 3 digits. Therefore, you have to take 3 digits from each step of operations. So we can expand this one. The 014 is nothing but 14. That's the interesting point. So what is 14 square? So that's equal to 196. The second step, 2AB. That's also very simple. 2 into 2 into 14. So it's easy to find. What is 2 into 14? That's equal to 28. Into 2. So what it will become? 56. So 2 into 2 into 14 is simply 56. And the last step, that is 2 square. So that is 2 square. And we are going to write down the answer, final answer. So I already mentioned the point that its rightmost group contains 3 digits. Therefore, you have to take 3 digits from each output. So first, 196. So our answers, last 3 digits, 196. Second step, there is not any other values here. We don't want to consider any carry forward type of operations here. Now we are moving to the next step, that is 56. But we need 3 digits. 56, it's only a 2-digit value. For filling the 3rd digit, you have to put a 0 on the left side. So therefore, you have to take that as 0, 5, 6. Clear? And the last step, what is 2 square? 2 square equal to 4. So a single digit value. Because that is the last step, you don't want to bother about whether how many digits over there or not. We just simply write that as 4. Or that as 004. If it is a single digit value, if you want to make it as a 3-digit expression, put 2 zeros on the left side. So there is no use because that's the last step. If it will be the in-between steps, you must follow the same result of the principle. Clear? So now we got it instantly. So 2014 square is nothing but 4056196. Got it clearly? This is a very effective and interesting way to find the squares of such large set of values. So keep that point in your mind. While considering this set of values, we applied only your skills of the squares up to 15 and the understanding about this identity. Suppose you just consider if you are able to by heart the squares up to 25 or 35 or 50, you can expand this range and you can save your time most. And try it with lots of other examples and make such wonders. And you have to make a clarification or the verification with the help of a calculator while we are doing the operations. Because we have to make a proper way of approach for such kind of squaring methods. Thanks for watching.